2.1 rectangular coordinates. And graphs. So you should have gotten yesterday the distance formula, which is the square root of x squared, or sorry, not x squared, x2 minus x1 squared plus y2 minus y1 squared. And then also the midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So basically, this section's pretty much just going to be using that. They ask you for basically the distance and the midpoint of the line segment with the 2 points that they give us. So starting with number 18, we have the point -8, 4, and another point 3, -5. So part A is the distance between them. So for that, we're going to have D equals the square root of, it is x2 minus x1. It doesn't matter which one you call x2 and which one you call x1 because it's getting squared, but you just need to be consistent. So if you use point P as 1 and Q as 2, just make sure you're consistent with that. So 3 minus negative, so plus 8 squared, plus, another parentheses, -5 minus 4 squared. So then that's 11 squared, which is 121, plus -9 squared would be 81. So that ends up being the square root of 202, I think. Yeah. And then it asks us for the midpoint. And you could break this down if you wanted to, but I'm okay if you leave it or just get like the decimal number if you type it in your calculator and say that as well. That would be fine, but I don't have my calculator handy, so. So then midpoint. So these are always going to be a coordinate pair, okay? So it's going to give you a coordinate pair, an ordered pair. So we just add the two x values together, divide by 2, add the y values together, divide by 2. So -8 plus 3 divided by 2, and 4 plus a negative, so -5 divided by 2. So this ends up giving us -5/2 and -1/2 would be our midpoint, and that would be all you have to do. So slightly easier math than what we've been doing probably. All right, I'm not going to do another one of those specifically because we're going to be using the distance formula and stuff throughout the section. So I'm going to jump to the next thing because basically as long as you know how to plug in points to the distance formula, that's really all this section is. So the next one say to determine whether the 3 points are the vertices of a right triangle. So basically they're going to give us 3 points. So we'll look at number 26. The point -2, -5. 1, 7, and 3, 15. And we are going to use the distance formula between each point. So basically, I'm going to have point A, point B, and point C. And I'm going to do the distance from A to B and get that number. I'm going to do the distance from B to C and get that number. And then I'm going to do the distance from A to C and get that number. And then I will take the biggest number, the biggest distance, make that my hypotenuse, and then use the Pythagorean theorem to verify if it's a right triangle or not. So it's just application of the distance formula now. So I would label, when you do like your distance formulas, I would say label them like the distance from A to B, for one, so that way you know what it is, and then two, it also helps me to see it when I'm checking your work, just to know. So we're going to have, I'm going to have point B be the second one. So 1 minus a negative, so plus 2 squared, plus 7 minus negative, so plus 5 squared, so that ends up being the square root of 3 squared is 9, plus 12 squared is 144, and so this ends up being the square root of 153. Now, I wouldn't try to take anything out when you're doing these problems because we're plugging it into the Pythagorean theorem, and what happens to every term in the Pythagorean theorem? It gets what? Squared. So a square is going to undo a square root, and I'll just be left with a number. So I would just leave it rather than taking things out because it'll just make your life easier. All right, so that's our first one. So that's the distance between A and B. So now I'm going to do the distance between B and C. The square root of 3 minus 1 squared plus 15 minus 7 squared. So that's the square root of 2 squared, so it's 4, plus 8 squared is 64. So this is going to be the square root of 68. And then now I need to do it between A and C. So square root of 3 minus negative, so 3 plus 2 squared, plus 15 minus negative, so plus 5 squared. So that's the square root of 5 squared is 25, plus 20 squared is 400. So that's going to be the square root of 425. So which side is going to be my hypotenuse?
A and C.
Yep, A to C. So I'm going to set up Pythagorean theorem. So the square root of 153 squared plus the square root of 68 squared is equal to the square root of 425 squared. And then with this, we just work down left and right individually. Don't like move stuff over. So the square roots are all going to cancel. So I have 153 plus 68 is equal to 425. And so this ends up being 221 is equal to 425. And since these are not equal, it is not a right triangle. So all that work to be able to say it's not a right triangle. Any questions about that part? All right, the last thing is if it's collinear, which is probably something you haven't really seen before. I guess there's a chance you may have seen it in geometry. But that's basically they give us 3 points, and it says that they have to be, according to the notes, 3 points are collinear if the sum of the distances between 2 pairs of the points is equal to the distance between their remaining pair of points. So if we have 2 sums or 2 of the distances that we add together and it's equal to the third one, then it is collinear. So 32, the point -1, -3, point -5, 12, and the point 1, -11. So I'm going to call them A, B, and C again. So I'm going to do, again, basically 3 distance formulas, same way I did for the triangle problem. So distance between A to B, square root of -5 minus negative, so +1 squared, plus 12 minus negative, so +3 squared. So that's the square root of -4 squared is 16, plus 15 squared is 225. Yeah. So that ends up being the square root of 241. Tori, can you find out what that decimal is out to like 2 decimal places? So with these ones, you will actually need to figure out the decimal number so that we can add, like eventually we'll be able to add them together. 15.52. Okay. So we'll hold that number for later. So then I'm going to do the distance from B to C. So it's the square root of 1 minus negative, so +5 squared, plus -11 minus 12 squared. So then that's the square root of 6 squared is 36, plus, oh goodness. Tori, can you square 23 and tell me what it is? Or -23, but it's going to end up giving the same thing. 529. Thanks. I do not know that one off the top of my head. So 529, so then this ends up being the square root of 565. And then can you do that square root? 23.77. And then the last one, the distance between A and C. Square root of 1 minus negative, so +1 squared, plus -11 minus negative, so +3 squared. So that's the square root of 2 squared, so 4 plus -8 squared, 64. So that's the square root of 68. So now we take the smallest 2 values that we got and we add them up to see if it equals the biggest one. Because if they're collinear, if we add them together, they should be equal to the third point. So 15.52 plus 8.25, we get 7.3, so 23.77. Those are equal. So these are collinear. And if they came out to not be equal, then it's not. Now, because of rounding, if it's off by like 0.1, 0.2, something like that, or even like 0.01 or 0.02, still consider them to be collinear because it could have been a rounding thing, potentially that led to that, but not like drastically different, obviously. But if just like the decimal is a little different, then you can assume that they're collinear. So, any questions on that? Good. Cool. Then your problems are It's a lot. I'm gonna warn you. 15, 23, 27, and 33. They just are like long problems. I just feel like they just take a while, but they're not hard, I don't think. So probably a good bit easier than what we've been doing. So anyways, there's that.